Hello, it's Keith from Kinvert, and in this video we're going to be going over solving inequalities in algebra. Let's just dive into an example. So if you have 2x plus 2 is greater than or equal to 6, what we want to do is just basically treat this like any other algebra problem. So we're going to go in and first get rid of the constants, and so this is going to leave us with 2x is greater than or equal to 4 because we've taken away 2 from both sides. Now we want to isolate x away from the coefficients. So we're going to divide both sides by 2, and this is going to result in x is greater than or equal to 2. And let's give this a sanity check. Let's say that this is a 2. So 2 times 2, we've got 4 plus 2, that's a 6, that's equal to 6. And let's say that x is a 3. 3 times 2, so that's 6 plus 2, we get 8. 8 is greater than 6. So this is looking like a good answer. All right, but what happens if we have a negative in here? Negative 2x plus 2 is greater than or equal to 6. All right. Well, we're going to start off with the same steps. Isolate the constant away from x, and we end up with negative 2x is greater than or equal to 4. And now what we want to do is isolate away the constant. So we're going to divide both sides by negative 2, and this is going to get us x, and here we have a negative 2. Because 4 divided by negative 2 is negative 2. But since we multiplied or divided both sides by a negative, we need to flip the inequality. So now it goes like this. So x is less than or equal to negative 2. Let me write this a little more clearly. That didn't come out great. So x is less than or equal to negative 2. All right, and let's give this one a sanity check. If x is, let's call x a positive 2. What if x is positive 2? Okay, so negative 2 times positive 2, so we've got negative 4 plus 2, that's negative 2, so this would not be true. Now let's put in a negative 2, all right? Negative 2 times negative 2, that's a 4, right? Because 2 negatives, so this is 4, plus 2, that's 6. That's looking good. Okay, so now let's see what happens if we have x is less than negative 2. So what about x is negative 3? Negative 2 times negative 3 is positive 6, and positive 6 plus 2 is 8, which is greater than 6. So this one's checking out. Now let's try another example over here, and let's just say that we have 2x minus 2 is greater than or equal to 6. Okay? So what's going to happen here? Well, we need to cancel the 2 on both sides. But now that this is a negative, do we need to swap the sign of this? Okay? And I think the answer is no. Let's check that. So let's continue solving this problem. Now we have 2x is greater than or equal to 8. And now we want to divide both sides by 2. And since this is a positive, I am again going to leave the direction of the inequality the same as before. X is greater than or equal to 4. And now we can test this, okay? So let's go with 4. 2 times 4, that's 8. 8 minus 2 is 6. So this satisfies greater than or equal to. What if x is greater than 4? So let's go to 5. 2 times 5 is 10. 10 minus 2 is 8, and that is greater than 6. So this checks out. So remember that you are only swapping the direction of the inequality if you are multiplying by a negative or if you are dividing by a negative. This is not true if you are adding or subtracting or anything like that, that does not apply. You only flip the signs when you are doing it this way, when you're multiplying or dividing by a negative. Okay, so we went over some examples of solving inequalities. This is Keith from Kinvert, and I hope you found this useful. Thanks a lot. Bye.